Hello everyone, and welcome. Today we're going to take a look at something in math that sometimes looks a little tricky. We're talking about exponents, but I promise our goal today is to make them super simple, super clear, and you know what? Maybe even a little bit fun. So let's get right into it.
Have you ever been looking at a math problem and seen one of those little numbers kind of floating next to a bigger one and just thought, what is that even supposed to mean? If you have, you are definitely not alone. It's a really common question, but trust me, by the end of our time together, you'll see it's actually a pretty simple and powerful idea. We're going to break it all down, step by step.
Okay, first things first. Let's start with the absolute basics. Before we can get into any of the cool rules or shortcuts, we've got to know what an exponent is in the first place and what its two main parts are called. So whenever you see something like this, there are always two parts. The big number, or in this case the letter A, that's what we call the base. And that little number up top, the 3, that's the exponent. The easiest way to think about it is that the exponent is like an instruction. It's telling you exactly how many times you need to multiply the base by itself.
So when we see a to the power of 3, it literally just means a times a times a. That's it. We're just multiplying a by itself 3 times. So using that same idea, what do you think x squared, or x with a little 2, would mean? Yep, it's just x times x. See, you've already got the main idea down.
Awesome. Now that we know what we're looking at, let's start building our exponent toolbox. This very first rule is a fantastic shortcut for when you need to multiply two powers that have the exact same base.
Let's look at our first problem together. We've got a to the power of 3, and we're multiplying it by a to the power of 2. So, how would we figure this out?
Well, before I show you the shortcut, let's just do it the long way so you can see why the shortcut works. We know a cubed is just a times a times a, and a squared is a times a. So if we multiply those together, how many a's do we have in total? Let's just count them up. 1, 2, 3, 4, 5. So our answer is a to the power of 5.
And that brings us to our very first shortcut. Did you notice anything about the original exponents, the 3 and the 2, and our final exponent, 5? That's right, 3 plus 2 equals 5. So here's the rule. When you multiply powers with the same base, you just add the exponents together. So a cubed times a squared becomes a to the power of 3 plus 2, which is a to the power of 5. Way faster, right?
Okay, it's your turn to try one. What is a times a to the power of 4? Now, I'll give you a little hint. Whenever you see a letter or a number all by itself, it secretly has an exponent of 1. We just don't usually write it. So a is really a to the power of 1. Go ahead and think about it for a second. Let's move on and add the second tool to our toolbox. This next rule is for when things look a little fancier, like when you have a power that's being raised to another power. It might look complicated, but I promise the shortcut is just as easy as the first one. Okay, check this out. We have a squared inside parentheses and a 3 on the outside. What are those parentheses telling us to do here?
Well, that 3 on the outside is telling us to take everything inside the parentheses, the a squared, and multiply it by itself 3 times. So that gives us a squared times a squared times a squared. And hey, we already know how to solve this. This is just rule number 1. We just add the exponents, right? So 2 plus 2 plus 2 equals 6. Our answer is a to the power of 6.
But there's an even faster way. Take a look at those two exponents, the 2 and the 3. What's 2 times 3? It's 6, and that's our second shortcut. When you have a power raised to another power like this, you just multiply the exponents. It's a super fast way to get to the answer. All right, your turn again. What would you get for x cubed to the power of 5? Remember that new shortcut we just learned? Take a second. Got it? The rule says we just multiply the exponents. So 3 times 5 is 15. The final answer is x to the power of 15. You are really getting the hang of this. All right, team, we're on a roll. Time for rule number 3. And this one is all about division. Now, if multiplying meant we add exponents, what do you think dividing is going to mean? Let's take a look. There are 3 little parts to this rule, but they all make perfect sense.
When you're dividing powers, you're really only going to run into 3 different situations. Case number 1, the exponent on top is bigger. Case number 2, the exponents are exactly the same. And case number 3, the exponent on the bottom is bigger. Let's look at each one.
First up, what if the top exponent is bigger, like a to the power of 5 divided by a to the power of 2? Well, the shortcut here is to just subtract. You take the top exponent and subtract the bottom one. So 5 minus 2 is 3, and our answer is a cubed. Easy enough. Okay, what about case 2? This is when the exponents are exactly the same, like a cubed divided by a cubed. Now this one is actually super simple. Just think about it for a second. What is any number divided by itself, like 10 divided by 10? That's 1. A million divided by a million? Still 1. It's the same idea here. A cubed divided by a cubed is always 1.
And now for our last case. What happens if the bottom exponent is the bigger one, like a squared divided by a to the power of 5? We still subtract. 5 minus 2 is still 3. But since the bigger, heavier term was on the bottom, in the denominator, our answer has to stay on the bottom. So this gives us a fraction, 1 over a cubed. It's like the a's on top cancel out and the leftovers stay where they started, at the bottom.
We are here. Our last rule, rule number 4. And you know, I like to call this one the sharing rule, because that exponent on the outside of the parentheses, well, it's very generous, and it wants to share its power with every single thing on the inside. This rule works for things being multiplied or divided inside the parentheses. So if we have a times b cubed, that little exponent 3 gets shared with everything inside. It goes to the a and it goes to the b. So it becomes a cubed times b cubed. Same thing for fractions. If you have a over b to the power of 4, that 4 gets shared with the top and the bottom. So you get a to the power of 4 over b to the power of 4. And just like that, you've learned the 4 big rules of exponents. Your toolbox is officially full. So now for the final test. Let's try a problem that makes us use a couple of these rules all at once.
Okay, let's break this one down. Our problem is a squared to the power of 5 times a cubed. Now, we always handle the parentheses first. To figure out a squared to the power of 5, we need our power of a power rule, right? That was rule number 2. We multiply the exponents. So 2 times 5 gives us 10. That whole part becomes a to the power of 10. Okay, so now our problem is much simpler. It's just a to the power of 10 times a cubed. Which rule do we need now? That's rule number 1. We just add the exponents. 10 plus 3 is 13. So our final answer is a to the power of 13. See, you just stack the rules together one step at a time.
And there they are, your complete exponent toolbox. Let's do one last super quick review. Rule 1. When you're multiplying, you add the exponents. Rule 2. For a power raised to another power, you multiply. Rule 3. When you're dividing, you subtract. And Rule 4. An exponent on the outside of a group gets shared with everything inside. If you can remember those 4 rules, you're all set.
You did such an amazing job today. You know, math can seem really complicated, but it's mostly just about learning how to use different tools, kind of like building blocks. Today, you added 4 really powerful new blocks to your collection. The only thing left to do is to practice using them. The more you use these rules, the more natural they'll feel. Thanks so much for learning with me today, and keep up the great work.